Okay, so to do this problem, we're going to use an interesting version of u-substitution. So we're going to say the one technique we love to use is just take the denominator, whatever it is, and just let that be u. So I'm going to say let u equal 2x plus 3. Now, if I were to take du, that would give me 2 dx. And using inside-outside technique, I'd say, look, I don't have a 2 in my numerator, right? But I can put one in there. So if I put a 2 inside, then I'm going to put a 1/2 outside. And now the substitution will say I've got 2 dx. Okay. So therefore, my 2 dx is a perfect match, leaving me with a perfect substitution for du. So I now have 1/2 x over u du. Now, the problem is I can't have a mixture of x's and u's. So we're also going to take our u function here. We're going to take this u function and we're going to solve for x. So quite simply, we're just going to say let u equal 2x plus 3. I'm going to solve for x. So I'm going to subtract 3, then divide by 2. And now I have a substitution that I can use for x. Right? So what I'm going to say here is I have 1/2 times the antiderivative of u minus 3 over 2 all over u du. Now, this is useful because before I had a binomial in the denominator and a monomial in the numerator, and we can't split that up easily. But if I have a binomial in the numerator, so maybe if I had something like this, x plus 4 over 5, and a monomial in the denominator, we can rewrite that as two separate fractions. I can say this is x over 5 plus 4 over 5, right? So therefore, I mean, I just made that up. But therefore, because I did that, this u substitution gave me that same idea. So we're going to just do a little bit of algebra to kind of simplify this. So we make this u over 2 minus 3 over 2 all over u. And if, du. And if we want to, we can now rewrite this. I'm going to do it a little slow for a calculus student, but just because you're not with me live, I'm going to write it like this. So this would be that divided by u over 1 du. Then what we can do here is say, okay, this would be u over 2 minus 3 over 2 times the reciprocal, 1 over u. And now, because we have it written like this, we can distribute 1/2. So this would be u over 2u minus 3 over 2u du. And now my u's would divide, leaving me with 1/2 times the antiderivative of 1 over 2 minus 3 over 2 u du. And now we're ready to antiderive. So here we go. The antiderivative of 1/2 would be 1/2 u, because we're doing du, so it has to become a u. Then minus the 3/2 is the constant multiplier. So really, truthfully, how I see this is the antiderivative of just 1 over u du. 1 over u, that's natural log, plus c. Okay, so now moving right along, we're almost done here. We just have to say we didn't start with u, so we can't end with u. So I'm going to be left with 1/2 times 1/2. What was u? Where was u? All the way back up at the top. That was 2x plus 3. So we're going to say u is 2x plus 3 minus 3/2 times the natural log of the absolute value of 2x plus 3. And of course, plus c at the end. And if you wanted to, you could distribute this 1/2 through and do any kind of simplification that you would prefer. I'll just distribute this 1/2, which would give us 1/4. Well, actually, we could write that in the numerator. So the 2x plus 3 over 4 minus 3 times the natural log of the absolute value of 2x plus 3 over 4 plus c. All right, hope that helps.